Hello, students. I had someone ask a follow-up on question 20. So I'm going to go ahead and hit that. This is on 8 point, shoot, I think it's 8.3. Yeah, 8.3, number 20. So again, matchstick figures. Find the total number of matchsticks in the fourth figure. So again, you can you could even draw the shape if you're continuing with the idea that we just leave off a little space. My prior video said kind of take advantage of the fact that you're missing those two to put those two in. And what would you get if you had those two in there? And then create the sequence and then just remove two from each term. Well, let's take a look and see if we can't go about this maybe a different way. Okay, so a couple different ways we could do this, just like everything, right? Everything in math. There's more than one way to do it. Okay, so when I look at these shapes, again, I'm looking for in terms of n. Ooh, that's very thick. Let me dim that down just a little bit. That better? That's better. Okay. There we go. In terms of n. So remember here, n is the number of the term. So what does n equal? Well, the first one, n is 1, 2, 3, and then 4. And of course, it's going to keep going. Okay. But try to see connections. So what's changing each time? So here, for example, as I mentioned before, there's 2 matchsticks, then 2 matchsticks, then 2 matchsticks going vertically, then 2 matchsticks going across. There's a lot of 2s in this puzzle. Okay. Okay, what about the next one up? Well, now take a look. Now there's 3 going across and 3 going down and 3 going down here and 3 going down here and 3 going across here and 3 going. There's a lot of 3s in this one. So the key number in the first one is a 2. The key number in the second one is a 3, right? So again, if you look at that, you might be able to see a connection between that number and your value of n. And the next one, you guessed it, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'm counting a lot of 4s here. 4 is my happy number here. So what I'm noticing is a connection between the number of the sequence and this kind of magical how many across, how many down type of idea. So if I was doing it that way, I would come and say, okay, so now in general, right, how many of these do I have? So the first one, if I'm counting 2s, think about 2s, and I'm going to think about kind of horizontal. Okay, so here's a group of 2, here's a group of 2. This would be a group of a 2. You can kind of even picture it as a group of 2 and just say, but I'm missing one of it right there. Okay, so 3 groups of 2 this way and 3 groups of 2 going vertically, but again, I'm missing one of them. So what I have is 1, 2, 3, 4, 5, 6. I have 6 groups of 2, right? Now you could also say, well, I have 3 groups of 2 and then 3 groups of 2. That's fine. So why don't I write it that way? I have 3 groups of 2 plus 3 groups of 2. And then at the end, I got to remove those 2 at the end that I didn't really count. And I'll say minus 2. That is how many toothpicks are in the first one. Okay. Now, what you want to do when you're doing this is you kind of want to try to relate that back to the value of n. But let's move to the second one and see if the second one here, I'll give myself a little space, we'll do it right here. Okay, so now I'm going to do 3s. Okay, go vertically, or I guess I did horizontal first. I'll do horizontal first again. Okay, so I'm going to go across. 3, 3, 3, and 3. Again, I'm missing one, but that's okay. 1, 2, 3, that's 4 groups of 3. So I have 4 groups of 3. That's horizontal. Now go vertical. 1, 2, 3, 4 groups of 3. So 4 groups of 3 again. And then don't forget, I did 0 off those, so just make sure I take 2 away from it. Okay. There we go. Okay. Again, if you get stuck in this problem, you might get stuck because you're sitting looking at the number at the end because you added all of this up. In mathematics, we're trying to search for a pattern. So while we could find a pattern with those numbers, and I'll show that at the end, this is more about looking for the pattern along the way. So don't necessarily multiply right away. Don't necessarily add. You might be able to see the connection a little bit better. Let's try the next one. Okay. Now I'm dealing with fours. Okay, well, how many groups of 4 do I have in here? So I'll go with purple. Okay, so 1, 2, 3, 4, 5. And again, I'm missing a little one here. So I have 5 groups of 4 going horizontally. And now I'll go vertically. 1, 2, 3, 4, 5. And again, missing one here. 5 times 4. And then I'm missing 2 at the end. And what you can do is by doing it this way, where I'm not actually multiplying out and getting the actual value quite yet, is I can generalize now. So if you take a look, number 1 is what I started with, but I end up with a 3, a 2, a 3, a 2. The next number is a 2, and I end up with a 4, a 3, a 4, and a 3. Then a 3, 5 and 4, 5 and 4. And that allows me to say, I bet that as this continues, the amount of toothpicks in the nth square is going to be, and actually I need a little bit more room than that. I'm going to come down here. Sorry about that. The amount of toothpicks in the nth square is going to be, well, take a look. What was the first number? It was a 3. How does 3 relate back here? It's 2 more than that number. How does 4 relate back here? It's 2 more than that number. How does 5 relate back here? 2 more than that number. So I need n plus 2 times, now the number 2 comes up. 2 goes back here, 3 goes next, 4 goes next, and you can see that's just 1 bigger than your n value. Okay. Now at this point in time, you have options. One of the options is say, wait a minute, you're just adding the same thing twice. If you see that, put a 2 in front and you don't have to write plus the same thing again. And don't forget at the very end, we're going to take away 2. Okay, because we're taking away 2 on all of them. That one didn't change. See, it was minus 2, minus 2, minus 2, minus 2 because of the 2 that we kind of added in to make our pattern. There we go. That's, yeah, that's kind of the idea behind seeing it as like lines of toothpicks or matchsticks. Could you multiply this out? Absolutely, you could multiply this out, right? So you could multiply this out. You have 2 times n squared. So if I multiply n times n, then n times 1, so plus n, then 2 times n, and then 2 times 1. And then don't forget my minus 2. And then just distribute the 2 across. So 2n squared plus 2n plus 4n plus 4, take away 2. And then you find this, simplify this, you have 2n squareds. 2n plus 4n is 6n, and a plus 4 minus 2 is a plus 2. And that is how you can do it. There you go. So now what does that do for you, right? You have now created an explicit formula. You want to go back and try it out. Let's go back and try it out. T of 1. That's the first one. Now I should get 3 times 2, which is 6, plus 3 times 2, which is 6, minus 2. So I should get the number 10. Let's check it. 2 times 1 squared plus 6 times 1 plus 2. And so that gives me 2 plus 6 plus 2, which is 10. It works. Try the second one. Try T2. That's 2 times 2 squared plus 6 times 2 plus 2. Now, if you try the second one right here that we had, this is 4 times 3, which is 12, plus 4 times 3, which is 12. 12 plus 12 is 24. Take away 2 and I get 22. So I should get 22 out of this. Let's see. 2 times 2, 2 squared is 4, times 2 is 8. So I get 8 plus 12 plus 2. 8 plus 12 is 20, plus 2 is 22. So it checks out. Okay. That's one way to do it. Look for a pattern. Look for how that pattern relates back to the number of terms, and you'll be in pretty good shape. Okay. If you want to check the last one, you can. T3, again, this would be 20 plus 20, that's 40 minus 2, so it should be 38. Okay. There we go. Woo woo. All right. So that's the idea there. Other options, what else could you have done? If you wanted to focus solely on the numbers and you said, hey, it has to keep going up by this number every time, then what you're doing is finding the sums of sequences. And let's take a look at what I mean by that. So we had 10 in the first, we had 22 in the second, we had 38 in the third, dot, 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 dot. So if you take a common difference, you'll find 12. The next one is 16. Now, again, if you say this is going to continue on, the next one going up would be plus 20. So the next one here would be 58, and this would be a 20. Okay. So now pause for a second. All right. So if you were going to try to find, just ignore the top one for a second. Think about this sequence. If I had 12 plus 16 plus 20 plus as many as I wanted to add them all up, then this sequence goes up by 4 every time. So writing it forwards and backwards, I could use that technique from chapter 1 and 2. So there's my sum. I do need a general term, and I notice my common difference is 4, and my first term is 12. So I'm going to ignore the first piece and just do this one. And I could say my nth term is going to be 12 plus n minus 1 times my common difference of 4. Multiply that out, you get 4n minus 4, but plus 12 gives you plus 8. Okay, 4n plus 8. So if I want to do first, second, third, dot, 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 all the way out to 4n plus 8, that's what it would look like. And if I write it backwards, I get 4n plus 8 plus 4n plus 4 plus 4n plus dot, 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 all the way to 12. And then add them together. Again, this is what we did in first term in Math 105. This gives you 4n plus 20, 4n plus 20, dot, 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 dot. All of them are going to be 4n plus 20 because we add them up. And they're all the same, which means I can combine them. So I have 4n plus 20 times what? Times n terms. And that is 2 times what I want. So the sum of this is 4n plus 20 multiplied by n, because I have n terms, and divide by 2. Okay. Now that is what you can find for the sum of this sequence right here. Let's take a look at a few terms so you can kind of see the connection between why did he do that when that's not the sequence he really wanted. Okay, well, let's take a look. So if I give you this and I say, okay, let's find s, this is really s for any value of n. So s of 1, the sum of the first 1 term, would be 4 times 1 plus 20, whole thing times 1 divided by 2. What is that? 20 plus 4 is 24, divided by 2 is 12. Okay, so there's the 12, right? Perfect. S2, what do I get? Okay, well, let's see here. I get 4 times 2 plus 20, right? The whole thing times n. Okay, that's good. On all of that divided by 2, but n in this case is 2 because I'm dealing with the second term. 4 times 2, that's 8 plus 20. So I get 28, right? So again, looking pretty cool. I like the way that's going. S3, I put this in 4 times 3 plus 20, whole thing times 3 and divided by 2. 12 plus 20 is 32. 32 cut in half is 16 times 3 is 48. Okay. So these are the sums of this sequence right here. And it may not look quite as cool to you, but I'm going to lay them down right above the sequence we really did want to find. Let's take a look. Notice I get a 12. I get a 28. I get a 48. And if you wanted to find the 0 term, plug in 0. And you get 0. So I want you to take a look at these. And I want you to look at the sequence I made and the sequence we had over here. My sequence goes 0, 12, 28, 48. Yours goes 10, 22, 38, 48. If you notice, I could add 10 to every term and get yours. So I could just take this sequence right here and add 10 to each of yours. Now my term though starts with 12 as S1. So if I want your term, I just need to make sure that I'm starting with the appropriate piece. And that is how I could create this sequence. So that's a second approach to doing it where you look at the first differences. You realize those are arithmetic. and then you find the sum of the arithmetic, because that's really what you're doing, right? Because you would say 10 plus 12 gives me this, plus 16 gives me this, plus 20 gives me that. So really, you just add up the sums and it will give you that other sequence. Okay. Let's see here. Could we simplify this? I'm sure someone's saying that. Well, I have 4n plus 20. So yeah, I think we probably could. We probably could simplify this a little bit. The 4n plus 20 has a factor of 2. So that would be 2 times 2n plus 10, whole thing times n, divide by 2, and then the 2's go away. So this gives you 2n squared plus 10n right there. Okay. So there we go. That's the same as the sequence right over here. You plug in 1, you get 12. You plug in 2, you get 28. Plug in 3, you get 48. But what I want to do is I want to plug in 1 and I want to get 10 out. Now, so what we're going to do is we're going to take that sequence and just add 10 to it. And we may have to adjust the value of n just a bit so it starts at the right place, because we need the first one to start right here. Okay. So what I need to do is just make sure that my 0th term acts like the first term. So if I put in the number 1 here, I need it to act like a 0 in that one. So I want to do an n minus 1. And that way, when you put in a 1, it acts like this and gives me a 0, and then I add 10 to it. So I want s of n minus 1, and then I would just add 10 to that, and that will be your sequence right up there at the top. So I'd have 2 times n minus 1 squared plus 10 times n minus 1, and then the whole thing plus 10. And this n minus 1 squared is n squared minus 2n plus 1, 10n minus 10, again, but minus 10 plus 10, whoosh, whoosh, gone, right? And then over here, I end up here with 2n squared, minus 4n plus 2, and then I also have a plus 10n. So when I combine those, I am running out of space on this page. Let's see here, I'll just add a page. So I have 2n squared minus 4n, and let's go back, what was it? Plus 2, and then a plus 10n, that's what I had. And so if I simplify now, there are like terms. So I end up with 2n squared plus 6n plus 2, which is exactly the same thing we got the first time. So that's how we can go about and do it. Two different ways, couple ways to see it. This one is using sums of arithmetic sequences and then kind of adjusting for that first term. That's totally fine to use that one. Probably from what we've done in this class, maybe the first one might be a little bit more intuitive by just kind of saying, I wish I had 2 more matchsticks. Put them in there, and then you can see all of these little pairs that come up. So I think that's I'd probably defer to the first one, but some of you are asking, hey, is there a way I could use that other piece? And the answer is yes. Yeah, use what you did in this one. Okay. So there you go. Couple different techniques. Whatever way works for you works for me. And remember, you're going to be seeing students in your classes, so it's not a bad thing to see a different technique that maybe you wouldn't normally use, but you might be able to use it with your students. All right, off you go.